Um, well, last class we went through this part, and just maybe I'll today after this class I'll share the video for the last class as well as today's on. So we talked about data volume tools and the data types they can actually analyze. So we talked about the big data Hive Hadoop. Today an extension I'm adding Spark because I intend to use Spark because Hadoop is good, but it has a lot of limitations. So we talked about the three V's, which we eventually extended to five V's. Talked about the velocity, the volume. We added value and variety to them. Yeah. So veracity also. Then I also mentioned analytic tools. We started with Python, but we didn't have time. So I mentioned Jupyter that we will be sorry, downloading Jupyter Anaconda, or better still, just install basic Jupyter notebook. So today I want to just bring us to because I was told exams to start June, so I got that notification today, and I sorry, let me make a correction to this. Okay, so I decided to now jump into the practical section proper. So, but today we're just going to go through um the intro part, talk about why we want to use Spark. We have now presently up to Spark 4 and so on. So we're going to be looking at Spark 4. So and we have Hadoop also is like a loop, but the Hadoop is it has a lot of limitations, even though it was the first platform or that was applied to big data. And when we say big data, we remember we talked about data from video, data from social media, Twitter, Facebook, all those one, and network. We talked about those as being sources of our big data. So now let's look at the Hadoop briefly. We say it is what a distributed file system. That's the components of Hadoop. It has two basic components, what we call the HDFS and then the map reduce. These are the two parts that make up the Hadoop. Um, what Hadoop does is, like before this 2008 and so on, there was no way of analyzing big data. All we had was what we've always had. I'm sure you've heard about MATLAB, you heard about SPSS, you know about Excel and all those ones. But when data started getting quite large, analyzing company data, organization data became very, very difficult. Now remember that post-COVID also, most companies went to the cloud, so and data generation because physical contact with data became less, which was a known traditional system. So more of the productions went to the cloud, and in fact, it became also necessary to analyze social media data. Maybe from 2009, I think if I check my Facebook account, I think I joined Facebook 2009. So if you check all this also, it's coming up around that 2008, 2009, when all these social medias, came into existence, many of them between 2008, 9, and people started joining them, producing a lot of data from them. So it also became quite necessary to find a way of analyzing the huge volumes of data from those sources. So now Hadoop was the first big data analytics tool that came up. Hadoop did very well. What it does is split that large volume of data into smaller units, which is the method that has been generally adopted, in dealing with big data, because single systems can hardly kind of analyze, offer deep analytics to those such big data without splitting them. So let's say what I have is 10 gig of data, which is like the sample I showed here. This one in bold font is like kind of representing a huge sum of data. So what happens is one component in Hadoop has the functionality of distributing this into smaller chunks, you know. So let's say it's 10 gig and I have 10 computers, for instance. In this case, I'm showing like five different, four more units. So these four units can distribute whatever the main content in this um, big volume of data is. And then it can now be analyzed in small, small chunks. Then after analysis, all those chunks, the output from each of them will now be summed up again. And that's the different um, areas or four different machines that you use to analyze the large data. Output that they have will now be brought together again. Do you understand? So Hadoop has what we call HDFS. HDFS. This is the part of it that divides the data set into multiple chunks. So, like I said, there are two major components, the HDFS and the map reduce. So the large data that comes in will first be what divided into smaller chunks. And then the map reduce will now come in. Map reduce kind of allows processing of the data, like let's say, like in the last example, we had four units for processing. So each of these units will process simultaneously. System one is processing what it received. System two is processing three, four. Even if you have 10, all 10 will receive specific chunk from the large data set and process that chunk it receives. Let's say we have 10 systems in a cluster. We will talk about cluster when we get to the main business. So a cluster is simply just a group of computers that are connected together, interconnected computers. A group, you understand? So that's what a cluster is. Each of those clusters we call a node. Can I call it? I think we did that, mentioned that last class. Terminal, node, machine, whatever you call it. So it could be a server also, but for it to form a cluster, you have multiple systems connected to each other, sharing data. You understand? So that's what a cluster is. So now our Hadoop distributed file system is a giant, that's the major storage system. But this storage system divides what the data set into small chunks. And then these small chunks are stored in different machines. Now we'll be using these words interchangeably: computers, machines, nodes. Do you understand? So if I say computer and I say machine, I mean the same thing. Of course, we are in the cities MSc class, so we know that already. Now, the map reduce will allow parallel processing, simultaneous processing of the chunks that each computer receives, after which all those chunks will be put together. But there is a downside, there's a downside to Hadoop, which gave rise or which necessitated the bringing up of Spark. So what happens is that the Hadoop saves to disk. Like let's say I have, we say it's a large, giant storage system. So we're talking about a computer, right? That has a very
Mm.
high, has high storage capability. Okay, both the RAM, the disk, we expect it to be very high. Okay, now what it does is, as a job is sent, it distributes into smaller chunks and receives the smaller chunks are done independently in the different computers, put together and then returned as done. So when they return, it writes what has been returned to the disk. Whenever it needs to do a new job, it also retrieves it from the disk. So you know what it is to like write to your disk, go back to disk whenever there's updates, get file from disk, divide it into so many computers, wait for them to finish their work, put it together, write it to the disk again. So this actually brings about a delay, latency in the system, because writing to disk, whenever there's updates, whenever there's a new job, whenever, and little updates must be done from the disk. This results in in delay, in latency. It slows down the system, slows down the system. So as a result, organizations that were happy, using this to analyze it became, they saw the downside also. It was working well on big data, but it has this downside of slowing down your entire system, because everything that has to be done must be done from the disk. So as a result, Spark came up. Spark improved on the challenges of Hadoop. You know, I talked about the developer of Spark at the University of California and so on, but maybe you read of that later. So the challenges number one is that Spark it allows multiple languages. Java can be used, Python, we are using Python in this one. You have SQL, you have R, all can be used on Spark. So having their own platform, Spark for Java developer, PySpark, and so on. So that's one of the advantages. Another advantage it has over specific advantage that he uses to overcome Hadoop is that instead of writing to the disk, he writes to memory. That's what we call in-memory processing. Instead of processing in disk, anytime there's need for update or new job or whatever, this one is on the RAM. So of course it makes it 100 times faster. It is the speed of Spark is put at 100 times faster than Hadoop. So of course you can see the improvements and that Spark gives over Hadoop. So that's why it is presently still the preferred um, platform for analyzing big data. So apart from that, it has fault tolerance. Don't forget that many systems are working in a cluster, right? We're just giving an example. We say 10 systems, 20 systems, but at the organization level, we'll be talking, might be talking about hundreds of systems and even more. So imagine that one system fails, and every system is supposed to produce the chunk that has been given to them. And the result of your own chunk is required at the output collection center before it can be written as completed job. So imagine that one of the nodes in the cluster failed. So Spark has what we call resilient distributed data set, RDD, which helps it to be able to recover from um, such failure. Do you understand? It has what we call Spark Core. It's a data structure that is in its data structure that helps it recover when there is failure in any of the nodes. So that failed machine will not really lose the data, but the data in it will be recovered. So it won't really, let's say, at the, let's say, they're meeting, bringing in their output at a particular so and so point, and then one has failed. Then 99 brought in their output, remaining that one. So with RDD, even that lost data will be recovered, and then the output will be um, added to what is available. Another one is also scalability. Scalability is the ability to run on one system, multiple systems, even as you increase the number of computers, no shaking. It's able to scale up. So we uses AWS EMR. We'll go through all these, Google Cloud, Dataproc, and so on. These are data applications that helps you to scale. Now, I would say it handles complexities of writing distributed systems. Like, let's say, for instance, you're doing, what do you call it again? Language processing, right? And you need to get words that are related or whatever you're searching for. I need to write a program that will run and based on how you shared your chunks of data, all the complexities, you might not be the one to write them in detail. Spark provides kind of a high level um, capability. You won't go into details of writing the program manually or whatever. So once you are able to assign who is the worker, who is the manager, the cloud manager is able to, understand that this job needs to be distributed to these computers without you writing the code for that distribution. Okay. So this is just a sample. This class won't be long because from next class it will be 100% hands-on. I don't know if we're going to be doing a physical class or we continue this way, but I want everybody to be joining the class with a laptop because it's hands-on. So if I carry out a project, because after this week now we'll have tests. I think after my weekend class, today is what? Today is Thursday. I should have a class with you on Sunday evening by God's grace. So after that class now, which is a practical class, after that class now, we'll be having a test. So and that test, my test is usually hands-on. You come with your laptop to school. Whatever I've done with you in the practical, you reproduce it and send to me. So this is the other classes we'll be having will be practical. So uh, this is a sample of cluster, what we mean by cluster in Spark. I want us to just note the terminology. Cluster is what? Multiple systems that are interconnected. That you're sitting here, I'm sitting close to you, does not make us a cluster. Or we have 10 people in one room or in one class, or we are 100 carrying our laptops. It does not make us a cluster. What makes us a cluster is that we are interconnected. So my next class also, which is on Sunday, will be on SDN because if we are going to be interconnected, I'll teach us how to connect virtually. We don't need to buy, what do you call it again? We don't need to buy routers and switches and all that. We'll do virtual routers, virtual switches. So we'll do network um, connection using SDN, software defined network. So it will be like a virtualized network. We'll virtualize our router, our switch, and all that. Then we'll see how to connect. Um, that'll be on Sunday. So we're just going to look at the terminologies of Spark. Now entered, I've done all the analysis and intro I want to do, and I've entered into the core course that I want to use for big data, which is Apache Spark 4.0. Okay, so now we've talked about cluster, a group of computers that are connected to each other and can share data. So other terminologies, we have a node, which is a machine in the cluster. We have developer, which is the code generator's machine. It is also one of the machines in the cluster, but it is the one produces the code. Like if I'm my if I'm one of the systems in the cluster is mine. and I'm typing the code that is, carrying out maybe um chunk distribution, this and that, whatever it is I'm sending as job, and I'm sending codes from my system, maybe using Python or Java. So my system is in the cluster because it is interconnected, it's going to be interconnected to them. So that is the developer. The developer is also a machine or a computer that is inside the cluster, but it is the one from which codes are generated. Now we have the cluster manager, which is which manages everything in the cluster. One of the jobs of the cluster manager is to create what we call a driver. A driver is also a node in the system, but it acts as, we call it team lead. The team lead has the task of controlling how the job flows in the work system or in the cluster. Now the workers, let's say like the cluster I showed you here, we have 10 systems in 10 machines in this cluster. Now, if I have data that is just 10 gig, right? And this data, I saved it from after my Wireshark, use Wireshark to capture packets, and the size of data is 10 gig, and I saved the name as packet1.tsv. So if I'm going to share this 10 gig amongst these 10 computers, each of them will get what? Only 1 gig, right? So what if I don't want to put all the 10 computers to do this job? I want only 4 to do the job. Do you understand? So 4 of them should be getting 2.5 gig, 2.5 gig each. So that means the size of my cluster is 10. The number of workers is what? 4. Who can understand what I mean by that? Workers are those computers in the cluster that are put to the job. Because the fact that you have 100 computers in your cluster does not mean that you want to use all 100 for a particular job. Do you understand? So you might just say, okay, I have 100 computers, but this job is small now. Let me just use 5 computers. Let me just use 10. Do you understand? So those 5 or 10 that you're using is the size of your, they're called workers. While the cluster size is the number of computers, all of them, all the computers in the cluster. So like mine now, I have 10 computers in my cluster. The workers that I want to put to a job could be just 3 or 4. Now, if I'm putting 3 to work, one of them will be one will be driver. So that means 4 are working. Do you understand? Because by default, whether you like it or not, you must provide for one computer or one machine that will act as the driver. So, and that driver will have functions that it will be performing. Do you understand? Management of the entire process is the job of, and then it is the cluster manager that assigns the computer that will work as your driver. So these are like basic terminologies. We have cluster, node, developer, cluster manager, cluster size, workers, and driver. Okay. So now for Spark, there are two basic um, components also that are noticeable in Spark. There are more, but basically I decided to discuss these two. We have the Spark core and the Spark resilient distributed data set. So it is the core and this resilient distributed data set that actually empowers it, helps it to be fault tolerant, helps it to recover from faults when there is a failure and to be able to recover the files, not lose your files and so on. So I didn't think I want to stop here for today. Then I'll post all these. You can go on and just go through the rest. These ones are not important like that. So, but my next class will be the lab for Spark. I think we'll have 2 classes. One will be for SDN connection of our systems, of like to form a how to connect systems virtually because we are not going to be buying routers now. We will do virtual connection of systems in a network, how to do it, and then after that, the same day we'll get into task proper. So I want, if you have any questions, let me go through again, please. Any questions? Hello, if you have any question, our next class will be on Sunday by God's grace, 8 p.m. Hopefully, if my gen no disappointed me, but hopefully by 8 p.m. Any question?
Okay,
Okay,
ma.
good evening.
Good evening.
Okay, no question on you.
This from my end, I can't hear you. Maybe you put it in the chat.
That is talking any question.
Sorry?
It's okay.
Please put it in the chat. It's not
Okay, ma. I said good evening, ma.
What takes you up the video? You read display sign up.
If you have a question, please bring it up.
Okay, thanks. Visual simple test. Got a second. What's that? Okay.
Any other question? Any question? I'm not seeing any.
Okay, thank you, ma. I have a question. My question is, the last class you said you give us the PowerPoint slide.
Yeah, that's why, it wasn't a huge class, just like introductory. So I continued from where I stopped last class. So what I'll do today is you get the PowerPoint, you get the video for last class and this class.
Okay, next question is, you said we might be having a physical class so that
Yes.
might have a practical.
Even, this is like visualization. So Sunday class will launch us into, I'm not buying routers. I'm not buying, what I just want to teach you how to do it, how to configure maybe Cisco routers, switches, without having to buy it. You understand? Because since COVID now, most companies have gone to the cloud. So most things we do now, we do virtualization. So Sunday, I'll teach you how to do virtual connections. Okay. So you have provisioning of the routers, switches, and all those virtually. Then we'll have a cluster. I'll just demonstrate. Okay. Now, our physical class will come maybe if you want on Monday because we'll have tests, and the test will be this. I think you usually have your classes on Thursday. Yes, you have your class Thursday, so the next week Thursday will be our test. So I'll teach you on Sunday. If you're available Monday, if it's not enough, if you have questions and you want to see me physically, on Monday I'll be available because on Thursday we get right test. And that test is like for the semester, that's the continuous assessment. Many of you have not even paid departmental dues. The lab have not been in good use. We've not been using it so, but we've done a lot of innovations there from the last set. It really helped us. So if you say you don't pay your departmental dues, no come for my test. So
Oh, okay. I'm sorry to interrupt. And that Monday we are supposed to have Dr. Kumune's course. It's supposed to be from 9 a.m. to, he said, about 4 hours. I don't know. So I don't know when we'll be done with him, whether you'll still be available by then.
No, that's why I don't stress anybody. I try to put my own virtual so that people that live far and near can, if they have data, they can join. And my practicals will be done here too. It's like hands-on. So on Sunday we'll start with the practical.
Okay, no problem. We are available on Monday, though.
If you're available, no issue. That if you have questions from Sunday practicals, you are free to come over to my office.
Okay,
But
ma.
you,
Okay,
yes,
ma.
but please,
Then
Sunday, everyone should get laptop. What we're doing is not in a phone, join with phone. No, no, no. MSc Computer Science, we will pass the level of using phone to join. Seriously. Because there are a lot of things that your phone cannot handle. Seriously. When we start networking now, your phone can't handle it. Yes, go ahead if you have questions.
you promised to give us the unit course unit of the this thing we are doing this semester. Or we are supposed to submit our.
Remind me, don't submit it. Oh. Don't submit it.
Okay,
Normally,
ma.
what we don't submit it. Like others, we allow them to submit it during second semester. So that by then you've known who is it. The form has space for first semester and second semester, right? So
Yes,
even
ma.
if I'll post the details courses to you. We used to have our departmental on, but we still have that. What happens now is that the central body, the PG school, will produce and now downflow it to us. So don't submit yet until second semester when you receive the course allocation for second semester. You now know who will sign those forms for you. It's not in a hurry. We're not in a hurry to submit. Usually it's second semester they submit. So don't worry. Okay. Any other question? Hello.
Thank
I have put on your videos for attendance. All videos on.
Ma, please, I need the course outline.
That's what he just asked for. Course outline that contains the code, the unit. I'll send that to your platform so you can
Okay.
be. All right, videos on, please.
Okay.
We are taking. Who is snapping? Who is using laptop? Everybody's coming in with phone. Man, start practical. Man, don't just try me with telephone. Please. Okay, 1 minute. Hope I'm seeing everybody. Whose hand is this? Okay, so Opu Jacob, please. Okay. I'm seeing one, Daniel, Lovett, Ebuka, Kizito, Ndukwe, Happiness. There's somebody else that didn't use his name. Who is it? Who is it? Mroau. Please, you save your profile with your real name like others. Yeah, it's good because this attendance, you have to show with your name. At the end of the day, we use this attendance for grading also. So is there anybody I've not mentioned? Lovett is here. Ebuka is here. Wachuku Daniel, Izito, Ndupe Goodness. I'm seeing 13 people. That means there are more. That's mm, big document. Mm. So if you know I didn't mention your name, please indicate to so I get.
I didn't mention my name.
Okay, so am I right?
Yes, ma.
Okay,
I didn't hear my name, sir.
okay, I'm seeing now Sunday Chukwebuka, so Eke Etsuk,
Yes, sir.
Written Explore. I don't know your name now, please. Always use names. Please, let me capture
I've
this.
changed my
I
name.
didn't have my own name.
Let me capture this name. That's a few. Please, what you can do for me is to send it as chat. Written Explore. I don't know the name. I'm seeing Eze Jerry. Yes. Love it. Okay. I think I got it, but please put your name in the chat. Let me see. Thank you. Please, Sunday, if you have laptop, you know, go and borrow. What we are doing is serious business. And hey, my exam is practical. I don't write theory. Practical in the sense that you carry out the practical with your own system. Then your output is what you now write for me. So please, I'm begging. Come join the classes with your system. And after Sunday's class, you have an assignment to work on. Exam has reached, so I'm begging you. Another part done at this thing. All right, so good night, or put your name in the chat for me, please. Thank you and good night. See you on Sunday by God's grace.
Thank you, ma. Thank you, ma.
Thank you, man.
Yeah.
All right, thank